All right. Thanks everyone for joining. And again, so there's an interesting session, and it's kind of a follow-up session where in the previous session we were talking about how do we use Vault, that's the HashiCorp Vault, for managing secrets across different tools. Now, in continuation of the same, what we will do today is mainly focus on how do we use the HashiCorp Vault to pass or inject credentials to Kubernetes applications, which is running inside a pod. Okay, so that way, let's go through how do we install the Vault inside the cluster using Helm and understand what is this concept called SideCar agent, using which Kubernetes will be able to pull the secrets from the HashiCorp Vault. And we'll try to do this by running a small application. So that's the pretty much agenda for what we have today. And before we get started, again, why do we need? So if you look at the problem statement, now DevOps has been so popular in every organization. You have to think about automating your build pipelines, your deployment pipelines, your infrastructure. And that's where a new addition to DevOps is security. And that's when you can start looking at the whole market is focusing on implementing security at every level of your DevOps automation, which is simply called as DevSecOps, correct? So security in application, security in infrastructure, security in monitoring, that's what is most important for the companies now. So being that, now when we use Kubernetes to deploy our application inside a cluster or on a pod, now what are the problems that we face? So whenever we say an application needs some kind of sensitive data, okay, which could be like a password, or it could be some kind of certificate or some credential that you need to pass to the application while it is running. Okay. Now there are different methods using which you can store that credentials and the application can read. But talking about DevSecOps, we need to make sure whatever the way that we are handling these secrets for running the application should be a best practice and it should be secure, right? And another thing that we have to focus on the automation side, it should be easy to maintain. So this is where if you use some cloud-based credential managers, right, then what happens is your application needs to connect to those third-party tools and it needs to get the required secrets or the credentials and then start running. So in this way, you have to design your application to make sure that it connects to those third-party tools or third-party services and get the ability or get the secrets that is needed. But however, the main purpose of application should be only to have the functionality of running it, not to focus on these things. So this is one of the biggest problem that we have. Now, the second problem what we have is your application would be running, but there are many scenarios in which the sensitive data like the secret or a credential might get updated. So now, whenever this secret or the credential gets updated, your application has to also take the latest secret and then start running the application. So basically, your application should update the latest content. So now, for this, if your application is trying to fetch the secret from a third party tool, so then what happens whenever there is a change, then you have to redeploy your application. So what is redeploying? You have to stop and then start the application. So whenever you think of stopping and restarting your application, it's called as a downtime, and it is going to cause some issues in terms of how a customer is accessing. So this is where what we also have to start looking at is you have to separate your application functionality from how do you fetch the secrets that is needed to run the application. And regardless of whether you're updating your secrets or not, your application should not be worrying about running it again or redeploying it. Okay, so that's the second necessity what we have. And the third important thing, again, as I was saying, focus on DevSecOps is not just to store your credentials and ask Kubernetes to read it, but when you go to a cluster, many of us have access to it. So this is when in Kubernetes, you also have something called as authentication or role-based authentication. So you can control a user who is connecting to the Kubernetes, what he should do and what he should not do. So in that way, whatever the process that we are following in DevSecOps, we need to make sure not everyone has access to that application or the process. So that is where, how do we make sure the control is given only to certain people, not to everyone? So this is the requirement which DevSecOps starts saying. So that's where, even though we have Kubernetes and we also have a lot of other secret managing tools. Now, how do you combine these two in which you're going to get these three features where application should not be worrying about collecting the secrets. And second, application should not be redeploying or again querying for any update if the secret is updated. And the third thing is, if anyone logs into the cluster, not everyone should be given access to the secret. So how do you secure them? Okay. So keeping these three in mind, now, what's the solution that we are going to give? So that's what the HashiCorp Vault is all about. Now, in that, we are going to run your HashiCorp agent as something called as a sidecar container. Okay. Now, this is where before we look into the architecture, now let's try to quickly understand some of the basic concepts that is needed for us to go through the architecture. Now, in that, now we all know whatever application that we want to run inside a cluster will run inside a container, and the container is handled by a pod. So ideally, your application is deployed as pods. Now, inside the pod, you will be having a minimum of one container, okay, in which your application runs. So usually that is called as the main container. Okay. So usually a pod will have one main container in which your application runs. Now, in Kubernetes, we have a design pattern in which you can also run more than one containers. Okay. Now this is where the other containers that you try to run inside the pod along with your main container has different purpose. Okay. So that's where ideally we are going to see two new types of containers today. So one is your main container, another one is called as sidecar container, and the third one is called as init container. Okay, so that's when let's try to understand them a little bit. So the first pattern that I was talking about is a container called sidecar. Now it's a funny thing, but let's understand first the basic of what do you mean by a sidecar. So if you look at this diagram, so usually when you have a bike, correct? Now along with the bike, you can see something is being attached to it. Now this is typically called as the sidecar. Okay. So now what's the purpose of adding this? So the purpose of this additional seat that you attach to your bike is to help carry more load, and it also going to help people to sit on a separate seat but not on the actual bike. Okay, so that's where it runs along with your main bike. So as long as the main bike is running, this will also be running. If your main bike is stopped, you don't need this to be running anymore. But the focus here is it is isolating the seat. Isolating means now there could be a person who is sitting on the main bike. However, there can be additionally another person who can sit on the sidecar. Okay, so now if you focus in the same way, in Kubernetes, when you have a pod in which you have your main container, there will be lot of small services or other applications that you need to support running your main application. Okay. An example could be for logging purpose or for monitoring purpose, or even we can use it for collecting some secrets without the main container worrying about it. So that way, site containers are special containers which run along the main container, just like how we saw a sidecar in a bike. Okay. So that now what you have in the main container is the actual application which will be running, and customers or users will be using that. And what's the purpose of the sidecar container is to run that supporting services or application along with it. So that the main container's focus is to run your actual application, and sidecar is to help to run the supporting services isolated. So it's not getting mixed. Okay. So this is how, whenever you have such a requirement where you don't want the main application to do everything, but just to focus on running the functionality of the application, then start putting all those services into a container called sidecar container. Okay. Now, the next one, or the other pattern, what we have is called as init container. Now, as the name says, init means first. So even if you go back to your Linux, when you start your machine, the first process that gets started will be init process, which will have the parent ID 1. So now, many times when you create the pod, the first thing Kubernetes will do is start the main container. Basically, it will create and start the main container. But think of it like this. When your main container is started, assume it needs some additional files that you need to download from a URL, or you have to do a git clone, or it has to connect to some database and fetch some data, or it has to connect to another microservice and get some details from it. So if you want all these things to be available before your main container starts, how do you do it? And you don't want to do it separately, because this should happen whenever your actual main container is started. So this is when Kubernetes has another special container called init container. So what you can do, if you define a certain task that you want to run inside the init container, then as soon as the pod gets created, the first thing it will do is create the init container, and it will run whatever the tasks you have given. So this way, you can use this container to connect to another microservice, or connect to a database, or connect to a URL and get the details, or simply do a git clone and get whatever the necessary files or data that you want. So this is how init containers are the first containers which will run inside your pod. Then what happens? Now, init containers are designed in such a way, it will just run the tasks whatever you want only once. And we know that in a container, if there is no command or process running, the container will get stopped. And that is where, as soon as the task whatever you have given is completed inside the container, the init container will get stopped and it gets deleted. And then inside this pod, the main container will be created and started. So this is how, in this pattern, when you have a main container with init container, first pod will create the init container, run whatever that you want in it, and then after the init container gets stopped, it will go and start the main container. So this way, what will happen? The main container, when it starts, whatever the data that you want, it's already been collected by the init container. And if you want to share those files or content between these two containers, then you can use a volume which will be within the same pod. So this is how init containers are meant to run only once in the beginning, and it is meant to run once and stop. And only when it stops, the main container will start. So this is how in Kubernetes, you have to design your pod in such a way that if you want some task to be done before the main container is created, then you can use init containers. And if you want something as a service or a task which needs to run along with your main container, then you should start thinking of using sidecar containers. However, in our design today, we'll try to use both of them. Okay. Now, this is where going back to our original problem statement. So now assume in this example, I want my pod to read some secret from the HashiCorp vault. And let's say it is a credential for a database. Okay. So this is when what you have to do is first we need to run our vault inside the cluster. So usually anything inside the cluster, you need to run them as a pod. Okay. Now this is where what we have to do is first install our HashiCorp vault as a pod. Okay, now we'll go through the demonstration a little later, but just assume we already have the vault server running in a separate pod. Okay, and we have stored all the credentials that is needed in it. Then, when we design our application pod, like I said, before my main container starts, I need the secret to be collected from the vault server. Now, this is where what we are looking at is something before my application or the main container is started, I need to collect the data. So for this, the architecture, what we will be using is the vault server has something called as a vault agent. So the purpose of the agent is to collect or fetch the data from the server. Okay. So what we will do, we will try to create or we will design our pod in such a way we will have an init container first created, and inside the init container, we will have the vault agent running. Okay. So the purpose of running the vault agent is to fetch whatever the necessary credentials or the secrets that your main application needs. So in my example, I'm talking about getting a credential for a database. Okay. So what will happen now? As soon as your pod gets created, the init container will start, which will run the vault agent, and that will connect to the vault server and get the data, whatever it is needed. And as I said in the beginning, the purpose of init container is to run only once. Okay. So your vault agent will connect to the server only once, get the data and store it inside the container. Now, however, once the task is completed, the init container will stop. So anything stored inside a container will also get deleted along with the container. So this is when the pod has to be designed in such a way, the init container will have a volume associated or mounted to it. Okay. And the type of the volume, what we are going to have is mtdir. So now what happens? Whatever the data that you have collected using the agent will be stored inside the volume available in the pod. So now when the init container gets destroyed, the data, whatever the agent which has collected is already stored inside the volume. Okay. And then now the pod will be going ahead with creating the main container. And this is where your actual application will be running. So now when your main container runs, what happens? It will mount to the same volume, which is of the type mtdir. So whatever the credentials or the file that the agent has collected in the init container is already stored in the volume. And that will be mounted or injected inside your main container. So this is how when your main container starts running, it will already have the necessary data or the secrets available in a particular folder. Okay. Now this solves the first purpose, that is Before my application starts running, you would have the respective data. Okay. Now is the next point. So you run it. Now what happens? Let's say the secret or the sensitive data has been updated in the server. Now your main container or the application running inside the main container doesn't know anything about the new data that has been updated. Now, this is where in the design, we will also include a sidecar container to run along your main container. Okay. So now what will happen? We will have the same agent running as a sidecar container. So what is the purpose of sidecar container? As I was showing you the diagram, it will be running along with the main container always. Okay. So now the purpose of the sidecar container is to keep collecting the data from the vault server, and it will be updating in the same volume that you have in the pod. So now what will happen? As soon as the sidecar container fetches the latest data, the volume will be updated. So obviously your application will also get the latest credentials or the data from the server. So this is how, by using this sidecar injector method, when you create a pod at the beginning, your application will have the sensitive data. And at the same time, anyway, the server gets updated with the credentials, your application will also get the update. So this is how you make sure your application focuses on only running the functionality. And with the help of this Vault agent as a sidecar, you keep updating your application with the necessary data collected from the server. Okay. Now, this kind of covers only the 2 points. That is, your application is separated from collecting the data, and whenever the data gets updated in the server, your application also receives without redeploying. But what's about the third part? That is, in the DevSecOps, you need to focus on the security of who is doing. How do I control the access? And this is when in Kubernetes, we have something called as a service account. Because many of you, when you create a cluster using Minikube, if you have noted, you will be executing everything as root. In fact, you will be running everything as an admin. Now, that's not the right way to do. So this is where, when you're using the sidecar containers, what you have to do is create a service account for your cluster and associate that service account with your sidecar, which means when the sidecar is running, only if you're allowing it to run with this service account, it will be having the permission to fetch the details from the server. Okay. However, for this, what we also have to do is we need to set up something called as a policy in the server. So the policy should say which service account is allowed to read the data from the vault server. So you have to do these two things additionally. So you will run the init container, you will run a sidecar container, but when you run that sidecar container, you need to run it using this service account. And at the same time, when the service account connects to the server, you're going to tell the vault server that this service account has the ability to read. So for that, you need to create a policy and tell that you have the read access. So this is how only when this service account from the cluster, that is the Kubernetes cluster, connects to the vault server, it is allowed to read the data. So no one else can connect to your vault server. So that's how you make sure your entire process of collecting the data or collecting this sensitive data is also secure. Okay. So let's try to do the demo of what we just now saw. Okay. Now for this, I have already a Minikube cluster running. Okay. And in that Minikube cluster, I have Helm chart installed. Now, if you're wondering, why do I need Helm for this? Now, again, this is most important because whenever I say I'm going to deploy something in Kubernetes, okay, So you need to define a YAML file, which we call it as the deployment manifest file. Now in that, you're going to tell what image to take, how the pod is going to run. Like now we have to define so many things on how do you create the init container, how do you create the sidecar container. Suppose if you want to access, you need to have a volume definition and service definition. Now, instead of defining multiple YAML files, so Kubernetes uses the concept called packaging or package management. So which is typically what we call it as Helm. So what we will do now, to install the Vault server, we will use the Helm package, which is available in the open source. Okay. So pretty much this is my Minikube cluster, or the machine in which I have Minikube. And let me just show you. So I have a single machine, that's the Minikube server. Okay. And right now I don't have anything in it, and I already have Helm installed. Okay. So what we will do first, we need to make sure that we are able to download and install a Helm chart. For that, what is the location of the repository? So that we will try to add. So I'm just telling this is the location from where we will try to install the Helm package for Vault server. Okay. And then go ahead and just do a repo update. So it says everything is up to date. And now I'll go ahead and run this command wherein I'm saying install a new release in my machine called as Vault, and the name of the package, that is the Helm package, is HashiCorp Vault. Now while it is running, now we are not trying to use Vault server for a production level. So right now it's more for a demo, and it's easy if you run the Vault server in a dev mode. So that's where I'm trying to pass a value to overwrite in the default values of the Helm package. So by this command, you will be running a pod and whatever the necessary things that we need in the default namespace, and the Vault server will be running on a dev mode. Okay. So let's go ahead and run this. Okay. Now it got deployed. So now if I just say kubectl get all, you can see that Helm package helped us to deploy not just a pod, but it also created a deployment object, a replica set, and you also have a stateful set object, and you also have different types of services, and you have your pods corresponding to this deployment and stateful set. Okay. Now, regardless of all these, finally, what we need is the pod. So just go ahead and say kubectl get pods, and you should see there are two pods running. Okay. So one is the server, and the other one is the agent, which is going to help us to communicate to the server. Okay. Now make sure both of them are up and running. So one by one. And what's more important for us is the Vault server, which is this Vault-0. So this is running as a stateful set. Why? Because where are we storing all the credentials? So we are going to store in the same pod, right? So that's where your Vault server is actually a stateful application. So because of that, whenever you are deploying or running a stateful application, you should use the type of the object as stateful set. So that's where you can see this. Okay. Now we have our Vault server up and running. Now for the demo, like I said, I want to store a credential for a database, which my application or pod needs it later. So for that, first, let's go inside the pod, because this is where we have our Vault. Now, you can access the Vault server using a UI or through command line. So for the sake of ease, I'm just using the command line utility so that you also get familiarized with the Kubernetes. So we have gone inside the Vault pod, which is nothing but the actual server. So now what we have to do is to store the credential. Now, this is where I said it's a follow-up session. So if you go back to the previous video and have a look, in Vault, before you store a data, you need to enable certain things called as a secret. So because for different types of credentials or different types of secret, you have different storage ability in the Vault server. So for that, now I will enable a secret of the type KV, which is key value pair. Okay. So first, let me enable it. So you can see it says in our Vault server, it is allowing us to store a key value pair. Now, the second thing what I'll do, I will try to put a new key value pair. Okay. So for my database, what I'm trying to do, I'm trying to store a key called username with the value Vesvatech DB admin and another key called password and a value as learn DevOps easy. So this is the key value pair that I'm storing into a location called internal database config. So whenever I refer to internal database config in my Vault server, it will retrieve me these two key and value. Okay. So first let's store this key value. All right. Now to confirm, let's try to run a command called vault kv get. Kv get means get the key value and which key value you want. So you can see it exactly shows that there are two key and value. One is username and password. Now this is what my application needs when it starts. Okay. Okay. So all you have done is set up a Vault server in a dev mode and you added one key value pair for your testing. Now, so if you recall on the authentication, I told you your Vault server should be allowing access only to a service account. So this is where what we will do is we need to first enable the authentication for Kubernetes. So that's where go back and now run this command called vault auth enable Kubernetes. That means Kubernetes can connect to your Vault server. So I'll run this command. So it says it is enabled. Then what you're going to do now is you're going to tell the location of your Kubernetes from which the access should be given. Now this is where when you try to run, you can see that I'm just adding a URL saying my Kubernetes host is running on port 443 on the same server, right? So that is what I'm trying to tell on where it should be. So once again, that has been stored as a data and I'm storing it into the Vault. Okay. So it added this information on where your Kubernetes host is available. Then we need to create a policy. Now this is the policy which we are saying if anyone wants, they can read this particular location and you are giving a read permission for it. So this is where you need to enable the policy so that when the Vault agent from the SideCar is trying to connect to the Vault server, it will be allowing the read action. Okay, so let me also go ahead and run it. So the policy is also updated. Okay, then what we have to do. Now this is where we have to create something called as a role. Okay, so a role is where you are tying up all those things, whatever that we defined. So what and all we defined? We defined a policy. We enabled the Kubernetes authentication. So now we are going to create something called as a role where you can see the name of the role is Vesvatech admin. Okay, this is again in the Vault server. And we are telling here, you bound this role to a service account called Vesvatech admin, which we haven't yet created on the Kubernetes, which we will do. But we are telling if this service account from Kubernetes cluster is trying to access, then you give this policy called Vesvatech admin, which is nothing but here. So You're telling when this service account of Kubernetes is trying to access this policy, you give him read permission. Okay. So that's where we are trying to tell what is the service account name and what is the policy name. Now I have kept all of them same so that it's easy for you to understand. Okay. So remember, this is the name of the service account and this is the name of the policy that we just created above. Okay. And what is this namespace? So in Kubernetes, you know, whatever you run as a pod is specifically inside a namespace. So that's where your service account is also going to be specific to a namespace. So that's what you're controlling. So you're telling only when I run a pod inside a namespace called default and I am using a service account called Vesvatech admin, I will be allowed to read the data from Vault server. Getting it? I'll repeat it. So this role is going to tell if only a person from Kubernetes, that is this location, and he's a service account of the name Vesvatech admin, and he's calling from a default namespace, only then you allow. So that is what this role is going to define. Okay. So go ahead and run this. All right. So we have defined the policy and we have also defined the role. Okay. Pretty much we have done with our first part, that is setting up your server. But now what we have to do, we need to deploy our application and we need to use a service account. Okay. Now this is where, let me go back. So I already have a YAML file here. Now out of this, let me show you this YAML file first. Okay. So I have taken a YAML file in which I'm trying to run a latest version of Apache as the image. You can replace it with anything you want. Now, I'm trying to run it as a deployment object. Why? Because in case if a pod gets crashed, it will be recreated by the deployment object. Okay. So I'm saying I need one replica and what is the name of the image is Apache. Now, the only thing that additionally what we need to do for this deployment is to use a service account. So I'm telling when you run this pod, run the pod as a service account called Vesvatech admin. So this should match the same what you have given in the role in the Vault server. Okay. However, we haven't created the service account. So this is where you can see I've also added another object to the same YAML file, which is we are creating a object of the type service account and the name is Vesvatech admin. So when I apply this, what will happen? It will run the pod and before that it will create a service account and it will be running as that user. Okay. Now, we haven't given any data about sidecar container. We haven't given any data about init container. Okay. So that's the first thing. Now, let me just show you first, how do you create a service account and how do we run it? Okay. So now, if I go ahead and say kubectl apply -f, so you can see it has created a service account and it has created our deployment object. Now, because of that, if I say kubectl get pods, so you have your vault and along with it, I have my Vesvatech sample application, which is the Apache running. Okay. Now, my expectation is when I run my application should access a file called a text file, which is available in a folder called Vault Secret Database Config. In fact, if you see, we haven't created the init container or sidecar container, and there is no volume also. So because of that, this folder itself will not be available in our containers. Okay. To cross check, you can go inside and just check kubectl exe, the pod name, and I'll just say ls. and Vault. So you can see the pod doesn't have anything. In fact, it has not read anything from the Vault server. So you don't have to do like this, but this is just for you to understand. So how do you add the details about init container and sidecar container? Now this is where the ability for a pod to run your init container and sidecar container can be given by a property called as annotation. So go back to your basics of your Kubernetes. So whenever you define object in the metadata, you can give a name, a label, or a namespace. Now, along with it, there is one more property of any object, which is called as annotation. Okay, so annotation has a special purpose. So that's exactly what we are going to do. So what we will do now, for the same existing object, what you have defined, you can add an annotation like this. Okay. Now, I have defined it separately so that you will now see the difference on how the init container and sidecar container are running. Okay. So what is this annotation? So in the spec of your deployment object, what we will do, we will add this new annotation in the metadata. Okay. And watch carefully. So here we are trying to tell there is two annotation called agent inject is true and agent inject status is update. So with the help of this annotation, your pod will get the ability to have a init container added as well as sidecar container added to the existing container. Because as of now, how many containers we have? So your deployment has only one container. Whereas whenever you add these two annotations to that, what will happen? You will get three containers altogether as a definition. So that is how annotation work. And not just that, we are also trying to give few more things. So we are telling when the sidecar container runs, what is the role that it has to use, which is Vesva-Tech admin. So again, don't get confused. This is not the service account name. This is the role that you created or the policy that you created here. So that's why I kept everything as the same name. So we are telling when the sidecar container runs, the Vault agent should use this role when it is connecting to the Vault server. Okay. And what is that you want to read? And that's what we are telling here. That is, go to this location on internal data database config, which is again, come back and go up. So this is where we stored this credentials, right? So we are trying to tell, read this data from the Vault server and where do you want to inject it inside your container? That is the main container, right? So that we are telling that it should be available in a location called this one. That is database config text. So by default, anything Vault agent is downloading, right? It will put into a folder called Vault secret. Okay. And what is the name of the file in which you should store it? We are calling it as database config. So the Vault agent will create this folder and fetch the data from this particular location of your Vault server and it will store it into a file called database config.txt. And that is what we are trying to tell in this. Okay. So this is the need for this 4 lines, but still you have one more last line here. What is this line called as? So again, what you need to know is we are not dealing with normal text data because all these are sensitive data. So whenever you are reading some data or some information from Vault server, it is not going to give you in a simple format. Okay. So this is where you need to read the data from the server and you need to convert it into more of a readable format. So that is what we do it here using something called as a template. Okay. So the Vault agent is going to use a template. So what is that template? So we are trying to tell, when you read the secret from this location, the final output, what we want to store inside this file, okay, should not be in a raw format, but you convert it into a format like this. Now, this is where I told you the example that I'm using is for connecting to a database. Assume the database is Postgres. So the final entry, if you look into this file, you will see something called as Postgres colon. What is the username that we have collected? The username is, we passed here, Vesvatech admin, and the password is learn DevOps easy. So the string, it will replace it and it will give you something like Postgres colon Vesvatech DB admin colon learn DevOps easy, which is the password at the rate whatever the port that you want to give. So you can see it will take this as a template and it will replace the value with the key and it will print it inside the specific file what you have given. So that's what exactly this annotation do. I'll just repeat again. This will tell to create the init container. This will tell to create the sidecar container. But when the container, that is the Vault agent, is going to connect to the server, it is going to use this role. And we are also telling, collect the information from this key value pair from the server and store it into this text file. And when you are doing it, use this as a template, and instead of storing the raw data, convert the data into this format. Okay, fine. Okay, now it got disconnected. Let me connect back. Okay, now what we should have actually done is, when we are defining the deployment YAML file, we should have added this annotation as the metadata. Now, however, since we have already created and it is running, I don't want to edit it again and change. So instead, what we will do, we will use a command called patch and we will update the metadata for the existing deployment object. Okay. Now, we have only one pod because we have defined one replica and you can see only one container is running. And I'll also show you, do a kubectl describe pod. So watch a couple of things. So this pod has only one container called Vesvatech demo. Okay. And go up. You can see it's having a default volume, but it doesn't have any new volume of the type mtdir. Okay. And it doesn't have any other container. There is only one container running, which is Vesvatech demo, and it is running the Apache image. So watch carefully what will happen. So now what we will do, we will go ahead and run this command. So what I'm doing, I'm trying to patch the existing deployment object, which is the name of this deployment object. Okay. You can also cross check that, kubectl get deploy. Okay. And for that, we are trying to read from this file. So that is the second file that I showed you. So let's go ahead and run this. Now, as soon as, okay, sorry, I'm in a different folder. Now I can run this. Now, as soon as you do, you can see it says it's patched. Quickly, let's go ahead and watch our pods, what's happening. Now pay attention. So what happened? Earlier, you had a pod which had only one container, but immediately as soon as you patched, what happened? You have two containers. In fact, you should have three containers. Why it is showing only two? Because what you have right now is only sidecar container and main container. Your init container has already started, collected the data, and it has stored into the volume and it has completed. So that is where the pod got recreated. In fact, what you have to understand is it's not the same pod. A new pod got created because of the annotation that we added. And now let's look at the definition of this. If I say kubectl describe pod, Okay, so you can see now a new pod got created, and in that, first it created a container called vault agent init, and this would have collected the text file, stored it with the format or a template what we want, and then after it stopped, it went ahead and ran our actual Apache container. And when it is running, you can also see side by side, there is one more container running called Vault Agent, which is the sidecar. Okay. So go up and you can confirm all of them. So you can see now in this pod, you had a init container. This is the container, and this was running your Vault Agent. Okay. And once it is done, it's supposed to be terminated. Now, once that is done, the next thing what it did is it started our main container, which is the Apache based image. And side by side, you can also see it's also running one more container, which is the sidecar container. So what is the purpose of this container? It's going to continuously check whether any new data has been there, and it is going to update your container accordingly. And now, how is this sharing the data? So now you can come down and look at this. So you can see you would have the additional volumes. So your init container is sharing the data through a mtdir volume, and your sidecar container is also sharing the data from a mtdir. Right now, it will not do anything because there is no new update. Okay. Now, first, let's confirm whether we have obtained all the data needed. So kubectl get pods. So this is the pod. So now let's go inside kubectl exe. Okay. So what I'll do, I'll just try to go inside the pod and I'll cat this file. So that earlier this vault folder itself was not there, but now the init container has already added, and look at the content. You see the difference? So we have a file called vault secret database config.txt. Now I'll also do a ls to show you. So who created this file? So this file was created by the init container with the help of vault agent. And second thing is, look at the content of this file. This is the content. Okay. So what is the content? This is the format what we just now told in the template, right? So let me show you that also. Look at this template. Okay. And look at the value. So it has replaced the username here and the password here. So this is how you can customize the template in such a way how you want the data, not the raw data. Okay. So this is how your init container helps to fetch the data. Okay. Now we have solved one problem, and we also use the secured way of service account. Only that will have access. Now the second thing I told you is what will happen if I do a update. Okay. So again, just look at the data. So what's the data we have? The username is Vesvatech DB admin, and the password is learn DevOps easy. Now this is what we have initially given in the beginning, correct? So now let us try to update this and see how the sidecar is helping us to update it into your pod. Okay. So what we will do for this now, I want you to watch again. I'll go inside this vault pod and I will add the existing key value. Okay. So we'll go inside it again. All right. And now I will now run the same command. Instead of the old value of Vesvatech DB admin and the password is learn DevOps easy, I'm just changing it to new user, new password. Okay. So run it. All right. Now quickly cross check. So you can see it's a second version. And now what is the value? New password, new user. So it got updated. Okay. Now quickly, let's go back and check whether your pod is getting updated. Now, usually for the first time, because of the network slowness, it would take around 5 to 10 minutes. Okay. Now, how do I confirm? Now, this is where you have a sidecar container running inside it, right? So let's monitor that. So the name of the sidecar container is Vault Agent. Okay. So what we will do, we can go ahead and just check this. So I'll say kubectl logs -f. This is the pod, but in this pod, I want to check for the container called Vault Agent. So I'm just checking for the sidecar container. Okay. Now you will get a message if it is reading. So we just have to wait for a couple of minutes. Okay. Let's wait. But the purpose here now is init container initially downloaded the data and it put into that folder. The purpose of site container is it will keep on checking the vault server, the same data when it gets updated, it will try to upload it. Okay, so that's what is going to happen. So let's wait for a couple of minutes. Yeah, initially it might take some time, but after that, it should be fast. Let's see if I can open another Git bash. Let me go back quickly to the server. Okay, so kubectl get pods. So this is the pod. So if I take this kubectl exe and I specifically want to connect to the Visvatech demo. Now, even if you don't give this, it'll always go by default only to that main container. Okay, so if I just say cat, okay, did you notice it just now updated dynamically? Okay, now it has read the data and because of that, it is mounting again. So your pod is still running, but what is the data now? It got updated with the new username and password. So what happened? Your pod was not crashed or redeployed, right? Look at this. It's the same pod. So when the data is updated, you don't have to redeploy your application. Only the data has been updated. So depending on that, your application can read this file and run. So this is how your sidecar containers will help to fetch the data continuously. And whenever it finds the data dynamically, it will take it up and it will update. So just note this point. Because of the type of value is key value pair, the vault agent will be storing this under a folder called vault secret. And this is the name of the file what we have given to store. Okay. So this is how using this sidecar injector method, you will be able to safely update your pods data whenever is needed. And not only that, you can also kind of tell without redeploying your application, you can make sure that you have the data updated. Okay. So that's pretty much now how do we use your sidecar container and init container. Okay. So pretty much moving forward, like I said, it's quite necessary that you need to know DevSecOps is not about using some credentials in your Kubernetes, but how sensitive is the data and how do you provide proper access to it? And at the same time, how do you make sure your application doesn't get stopped whenever a data or a secret has to be updated? All right. So that's for this session. And thanks for joining. And my name is Adam. Thank you.